Let's say f of x equals x minus 1 over x squared minus 1. This is a rational function. For a rational function, we should always think in terms of vertical asymptotes and horizontal asymptote. So always remember those. Good. We have to start with the domain. What would be the first step here? What do you recommend we should do? Because we have to start with the domain. Any suggestions? How would you start? It's okay if you're wrong. Just tell me what would you do first to find the domain. Anyone? How do we find the domain of such a function? What do I have to do first before I state the domain?
X is greater than or equal to 0.
But we don't have a square root. If I have a square root of x plus 3, then I have to write x plus 3 greater than or equal to 0. This is a rational function. So this is good for radical, because I can only take the square root from positive numbers and I can take the square root from 0. I cannot take the square root from -1, for example. So back to the rational. What do I have to do in order to find the domain of the rational? What did we do in the past with rationals always to find their domain? What could be the problem?
It can't be 0.
Where?
The denominator.
Correct. It cannot be 0 in the denominator. Good. So what do I have to do? How do I continue here? What do I have to write? Yes, you are correct. So x squared minus 1 cannot be 0. But what should I do?
You have to factor it out.
Very good. Okay, so let's factor the denominator. Perfect. That's all I needed. Yes. So how do I factor the denominator?
X minus 1, x plus 1.
And from here, of course, you already told me x cannot be plus or minus 1. I will start my table. Negative infinity, negative 1, 0, 1, infinity, and f prime, f of x, and f double prime. Because of this, I have to write nothing here and nothing here. But look what happens. I simplify a factor of x minus 1, and the simplified form is this. So what will x equals 1 be? What should I write here? What does it mean? What does the function have at x equals 1? The factor disappeared. What did we say? When the factor disappears, what will the function have at that point? So x equals 1 represents what? Yes?
Horizontal.
It's a whole.
Oh, okay.
If the factor goes away, that is a whole. What about x equals negative 1? What will x equals negative 1 represent? X plus 1 is still in the problem. What will that x equals negative 1 represent? For sure.
A vertical asymptote.
Very good. Excellent. For the horizontal asymptote, we have to determine the limits at infinity. So here we're talking about domain. So this is a vertical asymptote, but this one is not a vertical asymptote because the factor went away, disappeared. It's simplified. This is the new function. We're done with this. It's simplified to this. So now I have to plug in 0, and I get 1. I have to find these limits right here. So the limit as x approaches infinity from 1 over x plus 1, which will be the same with x approaches negative infinity. What do you think this limit is? Keeping in mind that x approaches infinity, what should this be? We had it several times today. We had it here, and we had it in the next example. So what does 1 over x plus 1, where does it go when x approaches infinity? What do you think? One over infinity, where will it go?
0.
Thank you very much, indeed. Of course, we wrote it 3 times today, right? 0, 0, y equals 0, horizontal asymptote. Perfect, awesome. Now I need to determine these limits. For the whole is easy. When I plug in 1 here, that's all I need to do. 1 over 2. This is a vertical asymptote, so I know left and right must be infinities, but I don't know the sign yet. So limit as x approaches 1 from the left from 1 over x plus 1, and then the limit as x approaches 1 from the right from 1 over x plus 1. Can anyone tell us? So the numerator goes to 1. What is the sign of the denominator? 1 from the left and 1 from the right. I'm sorry, this is negative 1. Sorry. So of course this is 0 and this is 0. But negative 1 from the left, can anyone give us the sign with negative 1.1 and with negative 0.9? From the left with negative 1.1, from the right with negative 0.9. What is the sign and what should I write?
Negative.
Yes, of course. Negative infinity and
Positive.
indeed. Negative, positive. So we finished with the function. Now we are ready to determine the derivative and study the sign. Of this function, we are talking about the simplified form. Please do not go back to the original one. That is done, gone. This is the one we are looking at. Okay, so I'm on page 9. So I'm going to copy the function. So f of x equals 1 over x plus 1. You know me, I prefer, because the numerator is just a number, I prefer x plus 1 raised to negative 1. You can use the quotient rule, but you have to be very careful because the numerator prime will be 0. So f prime of x, bring down negative 1 and subtract 1 from the power times the inner function prime, but that's 1. And this is negative 1 over x plus 1 squared. When you look at this expression, first question, can it be 0? Can this fraction be 0? When is a fraction 0? Anyone? When is a fraction 0?
And the denominator
Careful.
is 0.
Remember, when the denominator is 0, the function is undefined.
Oh, when the numerator.
Exactly. Awesome. Yes. Can the numerator be 0?
No.
No. So there is no critical number. Now, what is the sign of this expression? I covered that. What is the sign of just this? The sign of this. I covered that. Don't consider that yet. This.
Positive.
Always positive. It's positive so over something squared. But now please consider with the sign. What will this expression, what will be the sign of this expression forever then?
Negative.
Very good. I go back to my table. Now I have a moment of truth, right? I have to check and see what's going on. From 0 to negative infinity, yes, that's correct. From infinity to 1, yes, that's correct. From 1 to 1/2, I'm sorry, to 0.5, yes, correct. From 0.5 to 0, yes, that's correct. So indeed, the function is always decreasing. Now, finally, I'm going to look at the second derivative. So let's look at the second derivative. Here is the first derivative. In order to find the second derivative, I bring down -2, so it becomes 2, times x plus 1 to -3 times the inner function prime by the chain rule, but that's 1. 2 over x plus 1 to the third. I cannot draw the same conclusion. Power 2 is always positive, but power 3 can be positive or negative. But obviously it's not 0, because a fraction is 0 when the top is 0, but 2 is not 0. But I also need the sign. Okay, so one option would be I plug in -5. -5 plus 1 is negative, to the third power is negative. I plug in 0. 2 over 1, positive. I plug in 10, positive. When the second derivative is negative, the function does not hold water. When the second derivative is positive, the function holds water, and it holds water. That's all I need. It's done. Once I fill up the table, I know everything is here. I don't need anything else. Everything else is gibberish. Can go away. It's not useful anymore. Only my table. Nothing else matters. So when I graph this function, since it has two asymptotes, I will graph the asymptotes first. They're not part of the graph, but they have to be graphed. -1. And this is an overkill because it's already there. Now, on the left-hand side of the vertical asymptote, opening down, decreasing from 0 to -infinity. Easy. Here I have 0, 1. Here I have 1, 1/2. A whole. And now I read, decreasing all the time, coming from positive infinity, crossing at 0, 1, going through the hole, opening up, going through the hole, still opening up, decreasing to 0. Easy. So this is f of x minus 1 over x squared minus 1. Any questions? Any questions? And of course, if you try to check with the graphing calculator, you will not see this. So I encourage you to study the function on your own, find the first derivative, second derivative, as we just did, fill up the table, because punching in this graph in the graphing calculator will not give you this. It's there, but you will not be able to see it. Okay. Anything else that you would like to discuss? So that was done as well. Anything else? We can look at word problems with marginal profit, cost, revenue. Is that okay? Or you have something else in mind? Is anything that we need to review from the material from chapters? I don't have here. I do have this, but I don't have anything else from chapters 4, 5, and 6. Is there anything from 4, 5, and 6 that you would like to review? Any particular topic from 4, 5, and 6? Anything from 4, 5, and 6? Like integration. Definite and indefinite. Like partial derivatives. Like linear regression. Like differential equations. Like consumer surplus and producer surplus. Anyone needs any of these? What would you like to continue with? Any preference? Any preference?